The world of artificial intelligence, it's just moving at light speed, isn't it?
Absolutely. It's incredible.
You look at these large language models, how they grasp language. It feels like magic sometimes.
And the hardware, too, the parallel computing power we have now.
Yeah, it's transforming everything. Industries, our daily lives, you name it.
It really is exhilarating.
But, as AI gets bigger and more powerful, there's this growing question, right? Who actually controls it?
That's the core issue.
Because right now, most of the infrastructure, the data, the really powerful algorithms, it's mainly in the hands of just a few big corporations.
Which naturally leads to concerns. Security, privacy.
Exactly. Privacy is a
Yeah.
huge one. And fairness, too. You start wondering what actually happens to my data when it goes into these, like, massive centralized systems.
Yeah, who's behind the curtain? Who's making the decisions that affect you?
Who's really pulling the strings? Okay, let's unpack this.
What's fascinating here is these aren't just, theoretical worries. Centralized AI is efficient, no doubt. It's how we built a lot of what we use today.
Right. It works.
But it comes with real systemic risks baked in. You've got the potential for these huge data monopolies.
Where just a couple of players control vast amounts of information.
Exactly. And that creates single points of failure if one of those systems gets hit.
Uh-oh. Big problems.
Big problems. And then there's the whole black box issue. These systems can be so complex, it's hard to know why they make certain decisions.
Which raises flags about bias or misuse, even censorship, perhaps.
All of the above. And that's really where this idea, this concept of decentralized AI comes in as a really, a compelling alternative.
Okay.
The core idea is basically, let's rethink this. Let's distribute the processing, the storage, the decision-making across lots of different points in a network.
Instead of concentrating it all in one place.
Precisely. It's a fundamental reimagining of how we build, how we govern, and ultimately who owns these AI systems.
That does sound like a massive shift. And for our deep dive today, that's exactly what we're exploring, this move towards decentralization. Often, you hear about blockchain being involved, right? Technologies people might know from crypto.
Yeah, blockchain often plays a key role providing that trust layer.
And the promise here is essentially to democratize AI, make it more accessible, not just for the tech giants.
Right. More transparent, more secure for everyone, right down to the individual user.
So we're going to get into the nitty-gritty. The technologies making it happen, things like federated learning.
Trusted execution environments.
Exactly. We'll look at the benefits, the upsides, but also, let's be real, the challenges. Because it's not simple.
Definitely not. It's an emerging field, lots to figure out.
By the end of this, though, you should have a really solid grasp of where AI is potentially heading. Beyond the buzzwords, what does it actually mean for your privacy, your control, and, for innovation overall?
Sounds good.
So let's get right into it. Decentralized AI. It's more than just a trendy term, right?
Yeah.
How is it fundamentally different from the AI most of us interact with daily?
It really is a completely different architectural philosophy. Think about the standard model, OpenAI, Google, Microsoft. They build these enormous data centers.
Lots of investments.
Huge. And that's where their algorithms live, their models, the mountains of data they train on. It's efficient for massive scale computation, absolutely.
Right.
But it naturally creates those issues we just talked about. Data monopolies, concentrated control, single points of failure. If one of those central hubs goes offline and gets breached,
The impact could be huge, widespread.
exactly. Now, contrast that with decentralized AI. It spreads everything out, the compute power, the data storage, even the decision-making across a whole network of different, often independent nodes.
So like lots of smaller computers working together.
Kind of. Think of it like shifting from one giant, potentially vulnerable castle to a resilient network of many smaller, connected, secure outposts.
Okay, so it's not just a small tweak. It's a whole different way of thinking about building these systems. And a big driver for this, something that really hits home for people, is this concern around data privacy.
Oh, absolutely. Data sovereignty. It's massive.
Especially when you think about how much of our personal data is being fed into these large language models right now.
Think about it. Your chats, your photos, your search history, it all gets aggregated by a few companies to train their AIs.
Which raises big questions. Who owns my data? How safe is it?
Right. Decentralized AI aims to tackle that directly. In many of these systems, your raw, sensitive data can actually stay local. On your phone, on your laptop.
He doesn't get uploaded to some central cloud server.
Often, no, which dramatically cuts down the risk of those massive data breaches we keep hearing about. It puts you more in control.
Right.
Maybe only the insights learned from your data or anonymized updates to the model get shared across the network. Never the raw stuff itself.
They call it user data sovereignty, right?
Right. Exactly. You keep control, you keep ownership. Imagine, say, an AI learning from your health data to give you personalized advice, but that sensitive data never leaves your secure device. That's empowering.
That is a huge shift. We've seen so many breaches from big tech companies.
Year after year.
And not just breaches, but also worries about bias or maybe even censorship if AI development is controlled by just a few players.
Precisely. If only a few organizations dictate how AI develops, there's a real risk. Their agendas, their biases get baked into the systems that affect everyone.
And those systems might not align with what society actually wants or needs.
Exactly. Decentralization helps break that mold. It encourages a more open-source, community-driven approach.
More people involved.
More diverse developers, researchers, users, leading hopefully to more varied, more inclusive, and ultimately stronger AI models that serve a wider range of needs.
Okay, that makes sense.
Plus, a key advantage is transparency. If you use something like a blockchain to record the whole AI lifecycle,
Like how the data was collected, how the model was trained.
how it makes decisions, everything, recorded on an immutable ledger, that tackles the black box problem head on.
So you can actually see what happened.
Potentially.
Yeah.
Yes. You gain the ability to trace, to audit, to verify the AI's actions. That builds trust in a way that's really hard with opaque, centralized systems.
I can see that being vital, especially for critical things like, say, healthcare decisions or loan applications.
Absolutely. Imagine getting denied a loan and actually being able to see the steps, the data points that led to that decision instead of just getting a computer says no.
That level of transparency would be revolutionary.
Yeah.
But this sounds incredibly complex to actually build and run. What are the core technologies making this decentralized vision even possible?
It definitely involves a pretty sophisticated stack of tech working together. At the base layer, you often have blockchain technology.
Right, the ledger system.
Exactly. Not just for crypto, but here it acts as that secure, tamper-proof record keeper. It tracks transactions, data usage, model changes, ensuring integrity across the whole network.
So it's like the trust layer.
It's a crucial trust layer, yeah, providing that auditable, unchangeable history. Then, layered on top, you often find smart contracts.
Those self-executing agreements.
Right, coded onto the blockchain. They can automate things like compliance checks, handle secure data sharing based on preset conditions, even manage payments or incentives for people participating in the network, all without needing a middleman.
So a smart contract could release data to train a model only if certain privacy rules are met.
Precisely. Automating trust and compliance.
Okay, so that handles the trust and coordination layer. But how does the AI learning actually happen in this distributed way without sending all the data to one place?
That's where techniques like federated learning and edge AI come in. They're really critical.
Federated learning. Explain that a bit more.
Sure. It's a technique that lets AI models train across many different devices. Could be your phone, a sensor in a factory, a hospital server, without the raw, sensitive data ever leaving that device.
So the data stays put.
The data stays local and secure. Only the, let's call them learnings or anonymized model updates, are sent back to a central coordinator, which then combines these updates to improve the main global AI model.
Wow, so my phone could help improve a translation app, for instance, without my actual conversations ever leaving my device.
Exactly that. It's a massive win for privacy. Plus, it helps improve the models by training them on more diverse, real-world data from all these different sources, which can help reduce bias.
Less chance of bias if you're learning from a wider pool of data.
Potentially, yes. And working alongside federated learning is edge AI and distributed computing.
Edge AI, meaning the computing happens closer to where the data is generated.
Right. Closer to the edge of the network, on your phone, on an IoT device, on machinery. This means faster decisions because the data doesn't have to travel all the way to a central cloud and back.
Less lag.
Less lag, less reliance on expensive central servers, and better reliability, too. If one edge device fails, the rest of the network can often keep going. It removes that single point of failure.
Okay, that makes sense. Now, you also mentioned confidential computing and trusted execution environments, TEEs. How do they add another layer of privacy, especially if some participants in the network might not be fully trusted?
Ts are really interesting. They're basically hardware-based secure zones within a computer's processor, like a tiny, isolated black box
Inside the chip itself.
inside the chip. And computations involving sensitive data can happen inside this secure zone. The key thing is, the data and the code running inside the T are protected even from the owner or operator of the machine it's running on.
So even the person running the node can't peek inside.
That's the goal. They use hardware-level memory isolation and encryption, so you can process sensitive data with pretty minimal performance impact, but with strong confidentiality guarantees.
Like a secure vault for calculations.
A good analogy. Projects like Atoma Network, for instance, are really pushing how Ts can protect the inputs and outputs of AI tasks, even when they're running on potentially untrusted nodes in the network.
Okay, so multiple layers of security blockchain for auditability, federated learning for data locality, TEs for computation confidentiality.
Exactly, layering defenses.
But with all these distributed pieces,
Yeah.
storing data, making sure it's available, actually delivering the AI services across this huge network. How do you manage all that effectively? It sounds like a logistical nightmare.
It is a huge challenge, and that's where you see projects like Zero-G trying to build essentially a modular operating system for decentralized AI.
Operating system.
Yeah, they envision separate, specialized layers working together. A layer for storage, another critical layer for data availability, ensuring data is provably there when needed, and another for actually serving the data and AI results.
All coordinated somehow.
Coordinated by a consensus network, but designed to be permissionless. Their data availability layer, for example, isn't just storage. It's about guaranteeing you can verify the state off-chain. They use things like sharding, breaking data into pieces to try and achieve massive scalability.
Horizontal scalability, they call it.
Right, aiming to remove bottlenecks so AI can truly scale in a decentralized way. And for delivering the AI, they propose a decentralized serving network like a marketplace.
A marketplace.
Yeah, where providers can offer specific AI services, maybe fast data retrieval or running complex AI models and users can access them, perhaps paying with tokens.
Interesting. And space and time. They're tackling a similar problem, but focused on verifiable database queries, right? Using zero-knowledge proofs.
Exactly. Space and time is building a really crucial piece, allowing smart contracts to securely query traditional SQL databases, but get back results with cryptographic proof.
Proof that the query result is accurate and hasn't been tampered with.
Precisely. Without revealing unnecessary underlying data, they use their SXT token to run the network. It has different nodes. Indexers organize blockchain data. Provers run the SQL queries and generate those zero-knowledge proofs.
Which cryptographically guarantee the result.
Right. And then validator nodes check the proofs. This means an AI could base decisions on data pulled from various sources, but with a cryptographic guarantee that the data is correct and untampered.
So way beyond current systems where you just have to trust the data source.
Far beyond. Think about supply chains, finance, being able to query data and know cryptographically that the answer is trustworthy. That's huge.
Okay, this all sounds incredibly powerful. Transformative even. But there have to be downsides, big challenges to overcome before this becomes mainstream.
Oh, absolutely. The path forward is definitely not smooth yet. Two things come up again and again: complexity and scalability.
Complexity, meaning it's hard to build and use.
Very much so. Developers, companies, they need to learn whole new ways of thinking, new protocols, new security models. It's a steep learning curve.
And scalability. Distributed systems sound good for resilience, but are they fast enough?
That's the trade-off. Coordinating across potentially thousands or millions of nodes can introduce delays, latency. Getting internet-scale performance is a massive engineering challenge.
Right. And what about the data itself? If it's coming from all over the place.
Yeah, data consistency and standardization. How do you ensure quality? How do you make sure data from different sources can actually work together? Without strong standards, it can become a mess.
I can only imagine the legal side of things, too. Regulations must be lagging way behind this tech.
You hit a major nerve there. Existing rules like GDPR, they were mostly written for a centralized world.
How does right to be forgotten work on an immutable blockchain where data can't be deleted?
Exactly. It creates real tension. Plus, data flowing across borders in a decentralized network runs into a whole patchwork of different national laws. It's a legal minefield right now.
That uncertainty must slow things down.
It definitely does. And then there's the fundamental challenge of trust and consensus in a network where anyone could potentially join, including bad actors. You need really robust, secure, and efficient mechanisms to make sure everyone agrees on the state of the system.
So it's a constant balancing act between security, speed, and how decentralized you actually are.
A very tricky balancing act.
It seems like decentralization solves some big problems, like avoiding single points of control, but then introduces its own set of complex engineering and coordination hurdles.
That's a good way to put it.
What about the people involved? Do we have the right skills, the right organizational structures to make this happen?
That's another critical piece. Companies need to change how they think, moving towards what's some call data product thinking, treating data like a core asset.
And training people.
Big time. Upskilling is crucial, but even more challenging is just finding and keeping the talent. Data scientists, blockchain engineers, AI specialists who understand decentralized systems, and MLOps, the practices for actually deploying AI reliably.
MLOps, right.
Yeah, the demand for those skills vastly outstrips the supply right now. It's intense competition.
Okay, wow. We have covered a ton of ground today, really digging into how decentralized AI is. It's not just a small tweak. It feels like a fundamental rethink of how AI systems get built, how they're governed.
It really is.
We've seen how it pushes hard for user data sovereignty, giving you, the user, much more actual ownership and control over your digital footprint.
Which is huge.
And the potential for better security, much greater transparency, using those immutable ledgers to record everything, trying to get away from that black box AI where you just don't know why it did what it did.
Exactly. Moving towards auditable, verifiable systems.
That's right. And look, while decentralized AI is clearly still, well, it's early days, right?
Definitely in its infancy.
It faces huge hurdles, the complexity we talked about, getting it to scale, the engineering headaches of distributed systems, that whole regulatory puzzle.
Significant challenges, no doubt.
But the potential upside, it feels immense.
Okay.
Power to really transform the AI landscape.
I think so. This shift from data being scarce or locked up to potentially having abundant, diverse, high-quality data accessible for training, that could be a game changer for building better, less biased AI.
And empowering individuals, maybe letting you monetize your own data, turning it from something passively collected into an active asset.
That's part of the vision, redefining the digital economy. Plus, just the built-in resilience, the fault tolerance of these distributed systems. That feels really important for future-proofing AI as it gets embedded even deeper into everything we do.
Yeah, and as AI keeps evolving, you hear about autonomous AI agents, AI systems potentially governing things on blockchains, making financial decisions, or managing infrastructure.
The stakes get higher and higher.
Right. And the question of control, of trust, just becomes absolutely critical. Decentralized AI seems to offer a pathway, maybe the pathway, to ensure there's accountability.
To align what AI does with broader human values, prevent power concentrating too much.
Exactly. So thinking about all this, the challenges, but also the incredible promise, it makes you wonder, what role can you, listening right now, play in shaping this future?
Yeah.
An AI future that isn't just powerful, but also, fair, inclusive, and truly accountable.
It's a journey that's really just starting.
It really is. And understanding it, getting your head around it, that feels like a vital first step.